Hello, and welcome to our presentation on Robot Framework. So let's get started. So Murphy once said that anything that can go wrong will go wrong, which means that you can never know when things will go bad. And this is true for software as well. In fact, in a survey published in 2017, it was shown that there was $1.7 trillion in loss that occurred just because we couldn't test the right thing at the right time. So then what kind of testing should we do? So earlier it used to be a manual testing kind of thing where a person would do entire thing over and over again, but it was very slow and it was expensive because you had to hire more talent and stuff and less reliable. So automation testing was born, which was to use software to automate these testing procedure. This allowed cost-effective process and also a process of high quality. So now let's have a look at what Robot Framework really is.
So Robot Framework is a Python-based automation testing platform, which was developed as a master thesis project by Pekka Clark in Finland. And it is now widely used by various companies for automation testing. The main features is that it is quite keyword driven, and it offers a way in which the keywords are quite readable, like in normal English, so that everyone can understand. And also, you don't need to have much knowledge about coding to write a robot framework keywords and test cases. So that are the main features. But why Robot Framework? So Robot Framework offers a modular architecture in which all the modules are independent, so that you don't need to know anything about the other modules which are not in use. So it offers more easier to use syntax, as I already told, and offers a feature of tagging in which you can tag your test cases. Like if there are 1,000 test cases, you can tag 500 with different tags and another with different tags, so that you can run as per your tags. And reusability, as a separate library is written from which you can use the keywords any number of time. And it has a quite good stakeholder service, as in if you want to raise an issue or to add a feature, you can reach out to the stakeholders via Slack community or via GitHub issues, and they are quite fast in response and they offer you a quite good support. And now enough about the robot frameworks working, but we would see that now in a demo. We have made a simple test case to test a website. It is a test demo website available, and we are checking a shopping flow. So it's simple to use. I would just trigger a command and it would open the browser and perform the login flow and the shopping flow. And it is quite fast, like you can see, like everything happens super speed, and this is not possible manually. So this is where Robot Framework comes to picture, and it just is not a fast testing platform, but it also offers you a way to see the report. So as you can see, it offers a good quality report in which basic summary and details about it are written in a well way. So this is the best quality about Robot Framework. And now moving on to the stakeholders.
So a Robot Framework is truly an open source thing to its core. In fact, it's supported by a lot of foundation members, which give the investment and everything to support it. The excellent thing about this is, well, even if you are investing in the Robot Framework, there is an upper cap. So no company can truly, take control of the entire framework. And so a lot of different board members and working groups work together, and even individual contributors, to make this a success. So some companies that are part of this, like Nokia, which has been part since the beginning, as visible on the screen. So now we'll have a look at what the architecture is.
So RF architecture, as we said earlier, is modular architecture. So each module is actually independent on its own. So here we see a minimalistic container view of the same architecture. So here the users are the QA who wants to use the robot framework, and they use the robot framework through developing a file called .robot files, which contains the test cases and the test suits that they want to execute. And that files will be maintained in architect defined directory structure, and that directory structure will be given to the robot core in form of a command line argument. And in robot core, we do have this core processing Python files, which will process the .robot files provided by the users and then execute the test cases as per the need. And it also contains the API interfaces that are needed to communicate with the external libraries to interface with the system under test. Those external libraries, test libraries, are also part of the robot framework code, and they are also a separate container, and it can be developed individually by different users as it is an open source platform. And we do have a Rebot tool. Rebot is nothing but a report and log generator tool, and it, as we saw in the demo, it is the one that that produces the HTML that we can see as a report. And let's see the runtime overview of this same architecture. Like I told, the user provides the test suite as form of .robot files. robot is the robot core process this .robot file and process the keyword that is present in the file and interprets and acts accordingly and calls the necessary libraries and integration layer. That libraries and integration layer communicate with the system under test to produce the output XML file. That output XML file then received by the rebot tool to produce a report and logs, as we saw in the demo. It's a very good architecture as explained. So how to contribute to this? They use GitHub as many open source applications too. So in GitHub, they recommend to open an issue before raising a PR, even if you are coming up with an enhancement or a bug that you found in the robot framework. So that issue should contain a well-documented use case explanation that how you found a bug or how much the bug is reproducible, or if it is an enhancement, use cases as an enhancement. And then the lead developers come in to read the issue and then give suggestions, and also they tag the issue with proper priority and proper necessary tags like backward incompatible, and also they tag with some good tags like good first issue or help wanted, so that any new developers who wants to come in and contribute to the robot framework can look up for these tags and contribute to the robot framework. And also they link each issues with a milestone so that it can be tracked for each release. And then the pull requests are should have certain code conventions as per the Python standards, and also they should include a test and new test module so that it can be used for the CI/CD pipeline of the further pull requests.
Yeah, as we saw that the robot framework community really encourages a lot of contributors, but having such a huge contributor base also contributes to a few issues in the code health. We analyzed our code using tools like SonarQube and CodeScene, and we found out a few modules, they have redundant functions which can sort of can be covered with flags, so that would help refactoring in the future. Then there are some functions which have very nested if else condition blocks, so that also is very heavy on the memory and makes refactoring very difficult. So these code health issues, they do exist, but then if we look at the technical debt ratio, we find out that it's actually quite good. It's roughly around 0.2 right now, 0.02% of the entire code, and of that technical debt, a lot of it is attributed to the A-test and the U-test modules. It's a recognized issue, and like right now the contributions are going in along with those issues. On the right, you see that the increase in the complexity is actually very high as compared to the increase in the code length over the years, and this illustrates the code health issues that I just mentioned. Next. So let's talk about scalability, right? So it is no questions asked, a very important thing for any software solution to be scalable. But when we analyze robot framework scalability, we identify a few key challenges on the path. The first being, right now there is no provision to run the tests parallelly, and they right now are executed in a sequential manner. There have been efforts to parallelize the test runs, but they ran into some issues and they had to roll back those changes. So right now it's an open issue. Next, for example, if a tester has to test a web application, he would have to know the different versions corresponding to different driver versions corresponding to the different web browsers. So maintaining all these versions and dependencies is sort of an overhead for the QA. So that's also a challenge to scalability. And lastly, let's talk about the rebot module, which is responsible for logs and reporting. It's sort of a bottleneck right now when it comes to, so with every significant release, we see that it causes a degradation in performance and the load on memory, and it's a continuous effort to fix that. So yeah, these are the challenges for scalability.
We also did some performance analysis on the robot framework, and this was to see whether the number of cores and RAM influence the performance. So we took two different number of test cases, 10 and 50, and we tried to increase the cores and RAM. And we saw that, yeah, increasing the number of cores or increasing the RAM improves the performance a lot, especially so for larger amount of cases. The core actually helps because you can have better multi-core performance because you can parallelize stuff better. And this shows the robot framework's multi-core performance thing. And for the RAM, we see that, well, you don't have to go too much into the physical memory. So larger RAM helps in accelerate the process. And this was the performance analysis. And now we also propose few solutions and as an enhancement to the existing infrastructure. The first one is the RF cluster architecture. So right now, robot framework is an individual tool that's local to every device. But if you have a bigger team, it would make more sense to have clusters that each device offering different kind of test suite. This accelerates the speed and decreases the storage requirements. The second suggestion is the dependency manager. So dependency manager, because it just like we have Docker and stuff, it would make more sense to have a single tool that can install all dependencies and stuff in a single line of code. Finally, the performance test. Right now, whatever changes are being pushed, the CI/CD doesn't have any performance evaluation part of it. So it would be good to have a CI/CD pipeline enhancement that does the performance test as we go. So this was all. Thank you very much.